Okay, so some key information that we need from this question here. It says the stone is modeled of a particle and it's traveling in a straight line at constant speed. Okay, so the stone is originating at this point here. So this is the position vector OA, and this is the position vector OB. And like many vector questions, I've actually just sketched the diagram just to try and give me a feel for what's actually happening. Now we've been asked to prove that the stone passes through O, and because it travels in a straight line, then OA and OB, a straight line will pass through the origin O. In other words, the two vectors must be parallel. So we're trying to just produce a one vector is a multiple of another vector scenario. So let's write the vector as if we're going in this direction here. So I've got minus OA, which is the vector A to O, which is 24 and 10. And the vector OB, which is 12 and 5. So this looks to be a link between these two vectors here. And if I take out a factor of 2, I can see that this vector here, AO, is a multiple of this vector here, OB. So I can write it out like this. So AO is 2 lots of OB. So that's my indication there that the two vectors are parallel. They share a common point O, and this particle is traveling in a straight line, so it must pass through O. Just collect those together, put them to one side. And then focus on the next part of the question. So I'm being asked to find the speed of the stone. So I need to know the distance and the time. Well, we've got the time here. So t is equal to 4 seconds. Now I need to work out the distance. So it's going to be the magnitude of AB. So that's what I want to try and find. But let's find AB first. Okay, so let me just make a little vector sketch just to show it a little bit more clearly what's actually happening here to find AB. So this is my common point O there, and this is the vector B. I want to find AB, so we can see it's going to be equal to AO plus OB, which we can write as OB minus OA. And now I can substitute in those vectors there. So I've got 12, 5, take away minus 24 and minus 10. So that's going to give me 36 and 15 as my vector for that. So 36i plus 15j. I need to find the magnitude. So again, we're going to use Pythagoras to get that. That comes to, remarkably, that comes to 39. And therefore the speed, which is going to be 39 divided by 4, and that will give us 9.75 meters per second to 3 significant figures.